Co-planning a mathematics lesson in preparation for co-teaching is a form of professional learning that engages educators in meaningful and dynamic discussions about mathematical concepts, ideas, and strategies. This purposeful, professional dialogue assists teachers to not only plan for students, but to foster their own understandings and knowledge about the mathematics they are going to teach. Teachers learn from, with, and on behalf of one another. In the following presentation, educators will describe the steps they have taken to plan for the mathematics featured in this series on the three-part lesson. Begin with the Ontario curriculum. Use mathematical big ideas to effectively cluster expectations. Select or design an appropriate and challenging problem. Plan for the math by doing the math. Anticipate possible student solutions to the problem. As teachers plan for the three-part lesson and subsequent lessons, there is a focus on appropriate mathematics content and how to teach it. Anticipating where students are in relation to the content helps teachers to more effectively prepare for the learning.
The teacher looks at, what do the children know? What do I have evidence of their learning at this point in time? How can I use this learning to build on the learning that we want to happen next? And in the back of their mind, when teachers look at this kind of instruction, they're always keeping in the back of their mind, what is this roadmap of mathematics that I want my children to be on? What does the landscape look like? What are the key points or the big ideas that we want kids to begin to understand? What are the kinds of things that I need to engage them in so that they begin to investigate those big ideas?
The Ontario Mathematics curriculum provides the sequence of learning and serves as a resource for the common language and terms teachers and students need. When planning learning over a course of study, examination of the expectations within a grade ensures that lesson goals are informed by the curriculum. Comparison of expectations across grades assists teachers to become knowledgeable about how mathematical learning is sequenced. This knowledge helps teachers to anticipate and respond to the range of learning within a classroom.
When I plan, I try to first of all see where the students are, and then from there I like to see what they know, and I also look at the curriculum expectations because I need to know the big ideas. What do they need to know at the end? I like to make sure that I have them on a continuum, on a path along the way, knowing that I'm assessing them for learning to see what they are learning along the way. But I also like to make sure that I've covered the big ideas as I go along, which I've gotten from the curriculum.
Programs that are organized around big ideas or key concepts and focus on problem solving provide cohesive learning opportunities that allow students to explore mathematical concepts in depth. These large coherent chunks assist teachers to better help students achieve the expectations. The quality of a problem determines the richness of student talk. Classroom teacher Carol Hanna highlights the reasons for the selection of the problem chosen for the upcoming three-part lesson.
Okay, I've decided that my class is going to start fractions, and what we're going to do is we're going to do an initial or a startup kind of activity. So what we're going to do is we're going to take a certain amount of fractions and we're going to ask them to put it on a number line from 0 to 4. Okay. So, and then we're going to look at different ways kids are solving or putting the fractions on a number line. And because we're including a wide variety of different types of fractions, we're going to have mixed numbers, we're going to have improper fractions, we're going to allow for kids to choose the ones that they're most comfortable with, so that, or that they have an understanding of, or they're going to try and figure out. So even though there seems like there's a large number of fractions, which I think there's 14 or 15 of them, that they'll be able to, based on their prior knowledge, based on their comfort level and who they're working with and discussing with, they'll be able to plot the ones that they feel comfortable with. So even if they don't finish the whole, put all the fractions on the number line, that's okay. Because what we're looking at, what do they know? Because this is our first activity in fractions, so we want to assess their understanding. As part of the process here, we actually sit down and solve the problem individually, and then we've come together to discuss the solutions.
The problem that follows is one the students will solve during the three-part lesson featured in this resource, and it is recommended that educators pause here to solve it for themselves. Teachers further develop their understandings of mathematical concepts by solving the problems that will be used in the lessons with students. Actively working through a problem and solving it in more than one way in advance of the lesson helps teachers to begin to decompress their own mathematical knowledge and understandings. Pause the DVD here in order to solve the problem. Continue forward once each group has solved the problem in at least 2 ways. Now that you have solved the problem, share your solutions and your thinking with others. Consider, in what ways does this problem unpack key understandings, concepts, skills, and strategies about fractions? In what ways does the problem address the continuum of learning that might exist in a grade 6 classroom? Pause the DVD once again. In light of your own solutions, discuss these questions as you prepare yourselves mathematically for the 3-part lesson that will be used in this resource. Having solved the problem that will be used in the lesson, the teachers review the mathematical big ideas that the problem has drawn on. A focus on mathematical big ideas helps teachers to notice, describe, and discern the mathematical details and relationships among student solutions. They also serve as a starting point for educators to explore their own understandings of what is important to teach and learn.
And if we go back to the sort of big ideas in mathematics that we designed the lesson around, it's that idea that a fraction represents a quantity, just like a whole number represents a quantity, that any quantity can be ordered in terms of least to greatest, and that when you're referring to fractional quantities, there are a variety of ways to represent the same quantity. So those are the kinds of ideas that we mulled back in our minds when we designed the actual fractions that we chose.
And we picked ones also that would match benchmarks back. Benchmarks are a quarter, a half, 3/4, and a whole, which is something that they were introduced to in grade 4, which is one of the expectations. So it's that whole idea that equivalent fractions, if it's 8/4, is also the same as something else. We want those for them to start demonstrating or developing the whole idea of equivalency too.
And just that very big idea that a fraction represents a quantity, that's something that is not a robust understanding for most students. They see them as digits and they do things with them, and they have a fairly good sense of quantity in certain fractions, and a half seems to be the one that kids really understand what quantitatively a half is. But as soon as you move out from the half, it becomes more and more fragile, and the less frequently they see a fraction, for example 6 and 5ths, the less they'll have an understanding of where that actually would exist on a number line.
And even in grade 6, it's more getting past one whole. Like I find that when kids all of a sudden, it's an improper fraction or a mixed fraction, once you get past one whole, it no longer fits into their visualization of a, whether it be a rectangle or a circle or whatever they're knowledgeable about. They have a very difficult time getting past just the one whole.
Anticipating different ways in which students might solve the problem further prepares the teacher to examine the mathematics that will be found in the student's solutions.
And we also designed them and chose the fractions thinking about what kids might do. And we picked fractions that would be easy to relate to money, because kids will often relate to money. And then we also chose some fractions, for example 6, that are not an easy correlation to a money context. So we'll see what kids do with those fractions that are less easy to convert to a context that they're very familiar with.
Well, we talked in our planning too about we had done a similar problem last year, and some of the students had difficulty with the half. Like they saw when you went past the 0 to 1 number line into, in this case 0 to 4, they had trouble with some of the fractions they could plot on the 0 to 4, but then other ones they reverted back as if it were a 0 to 1 number line. So I'm kind of anticipating that we might see a little bit of crossover with where they place them.
I'm also wondering if some of the students will very quickly take some of the fractions and put them in a context that they're familiar with, for example money. And if they do that, will they immediately go to the fractions that they see as a direct correlation to money, and then what they will do with those fractions that are not fitting into that strategy particularly well. And so what will happen, will they revert to another strategy, or they'll lead them to one side? So it would just be interesting to see what they do.
I think also too, what I think some kids will do is that they will do the ones they're very familiar with, but when they come up to the one that's 5, 6, they will confuse the numerator and the denominator, which is bigger, which is smaller. I think, you know, I think that might be something that might be problematic for some students.
So some of the strategies that I was thinking of that I would see the kids working on with using pictorial, we talk a lot about, you know, food and breaking it up or something like that. I'm just not so sure, like the difference in in pictures would be kind of like the linear chocolate bar example, or the, you know, the, like, I guess yours is kind of linear too, the drawings that you've, on the line that you have there. But thinking back when you were first learning fractions, we always talked about pizzas and pies and that kind of thing. So I'm thinking that we're going to see a lot of pictures.
I think that's a really good point, because the area model is more robust for most students than the linear model.
Thank you.
We're asking them to represent on a linear model, and I think they'll go back. I think you're right. I think we're going to see the area model represented in some of their pictures, and then it will be interesting to see how they convert the area representation to the linear representation.
Okay, I think the kids are ready, so it's time for us to get going.
Okay.
Kids, go.